we're dealing with Pythagorean theorem. First, let me remind you what Pythagorean theorem is. If you have a right triangle, then the square of the hypotenuse, which the hypotenuse is C, is equal to the sum, right, the addition of the squares of the legs. A is a leg, and B is a leg, and C is the hypotenuse. The hypotenuse is the longest side. It is directly across from the right angle. It's the largest side, the longest side, because it's across from the largest angle. The Pythagorean theorem says a squared plus b squared is equal to c squared. The sum of the squares of the leg is equal to the square of the hypotenuse. That's what Pythagorean theorem says. So, some examples with Pythagorean theorem. Okay, solve for x. So you have to decide, every time you have to decide which is the hypotenuse. Always look for it. It's not always going to be on the same side. You can see all three of these triangles are rotated around where the right angle is in a different place. So in this case, here's my right angle, and here's my hypotenuse. Here's my right angle, here's my hypotenuse. Right angle, hypotenuse. Be careful, especially when they're looking like this. We always want to put them on the right-hand side or the left-hand side. Okay, so the two legs, a squared plus b squared. It doesn't matter which one is a and which one is b. I like my variable to be first if possible, so that's the reason I wrote it that way. Okay, so I would subtract 5 squared from both sides. You can simplify, but we can also handle this all at one time. Type it in your calculator. 13 squared minus 5 squared is 144. So x squared is 144. Okay, to fix that or to finish it out, we take the square root. So the square root of 144 is plus 12 or minus 12. We don't care about the minus 12 because I can't have a minus 12 or negative 12 as a side length. And so my side length then of the triangle would be 12. If this one, see we had a nice whole number, that was a perfect square, so it came out nice and easy. On this one, again, 10 is your hypotenuse, right? That's my C. It will be x squared plus a squared plus b squared is equal to c squared. Again, it doesn't matter which one's which. Now, if you do 10 squared minus 5 squared, you get that x squared is 75. Now, I need to point this out. It's not 10 minus 5 and then square it. Okay? It's not 10 minus 5 and then square it. It's 10 squared minus 5 squared. If you're going to do it all at once, you have to square it as you go. You can't do subtraction and then square. Order of operations says that you have to do those exponents first. Now the square root of 75, say you don't recognize it, the square root of 75 is a decimal. I asked you to leave your answer exact. That means you need to reduce your answer. Sorry, trying to keep it in focus. That doesn't like the calculator. So we're going to go back to what we just did. The biggest perfect square that goes into, right, I need to take the square root. The biggest perfect square that goes into 75 is 25. It would be the square root of 25 and times 3. So 25 times 3 is 75. The square root of 25 is 5, and the square root of 3 is a decimal. So the final answer is 5 times the square root of 3. That's the exact, because I didn't have to round. I didn't have to do anything with the decimals at all. This last one, be careful, right? X is now your hypotenuse. So we're going to square these two sides. It doesn't matter which one's which. Be careful here. It's 2 square root of 3 squared plus 2 squared is equal to x squared. What I'm afraid that some of you will do is this, 2 root 3 squared. And you'll type that in on your calculator that way. Well, what happens is only the square root of 3 is getting squared, not the 2. So, right, you can pick up your calculator and let the calculator handle that math for you. 2 square root of 3, and then square it. And it gives you 6. Okay, well, that's not right. So I know that's not right, so let me go back to square root of 3. Let me arrow out of this, right? Squared. That's exactly what would happen if you just squared the square root of 3. You should get 12. Here's the reason I knew that was wrong. Because 2 squared is 4. The square root of 3 squared is 3, so I knew that had to be 12. 12 plus 4 is equal to x squared. X squared is 16, or if you take the square root of both sides, you get plus 16 or negative 16, positive 16, negative 16. We don't need the, or, excuse me, 4 plus positive 4, negative 4. We don't need the negative because we can't have a negative side length, so the only one we keep is 4. Now, one of the things that we have that's nice with Pythagorean theorem is there are certain things that happen all the time, and they come out nice and pretty. No decimals, kind of like this one right here. Those are called Pythagorean triples. They're very, very useful in construction, especially. For instance, this summer I was laying tile in my bathroom, and I laid out where I was going to start my tile, and I needed to make sure that it was a right angle. So I had these 2 lines, and I wanted to lay my tile right here in that first corner, but I need to make sure it's square at a right angle. So what I did is I measured 3 inches out and 4 inches out, or 5 because I needed a little bit more, so I did 6 and 8. So I measured 6 inches out, and I measured 8 inches up, and then I measured this diagonal. And if that diagonal was 10, then I knew that that was a right angle because of these Pythagorean triples. If you pull that up, there are so many videos on YouTube that show you how to use Pythagorean triples to check to make sure that your corners are square if you're framing a window or a door or you're building a foundation or something like that. Anything, lots and lots, it's used in trade a lot. Now, the most common families that we use in Pythagorean triples are 3, 4, and 5, or any multiple of that. So 6, 8, 10. 3 times 2, 4 times 2, 5 times 2. So that would also be your 3x, 4x, or 5x. So 9, 12, 15. Those are all multiples of your Pythagorean triples. So we have a 3, 4, 5, a 5, 12, 13 triple, an 8, 15, 17 triple, and a 7, 24, 25. I would say these 2 right here are the most common of all the ones that we use. And once we get past this unit, we'll be using Pythagorean theorem all year long. But if you look, a lot of times they're triples. They're meant to be a shortcut. So do you have to use them? No. But let me show you where it's helpful. For instance, this problem right here. I have this trapezoid. It has these 2 right triangle ends on them. It's an isosceles trapezoid because we have our 2 sides being 13 here and here. Right? And so I want to find x. Well, x is the entire bottom of the trapezoid. Well, I know that if this side is 9, this side from here to here is 9, because that's a rectangle, has those right angles in there. And so I need to find that other piece. Well, you can go through the math, and you can say, well, 5 squared plus x, or we'll call this y, right? 5 squared plus y squared is equal to 13 squared. Or you can go, wait, if that's 5, and the hypotenuse is 13, right? 5 is the hypotenuse, 13 is the hypotenuse, 17, the longest side's the hypotenuse. 5 and 13, if that's 5 and 13, that means this side has to be 12. I don't even have to do Pythagorean theorem. I just know this is 12 and this is 12. I didn't have to do anything. You can, if you get stuck and you don't remember, you can always go back and do Pythagorean theorem. But there is great benefit to knowing those Pythagorean triples. They're really a time saver, especially on PSAT, SAT, ACT, stuff like that. So 12 plus 9 plus 12 is 33. So the length of that side is 33. Number 5, the problem is I want x. The problem is if you look at x, that right triangle doesn't have enough information because I don't have this side. And to use Pythagorean theorem, you have to know 2 of the 3 sides. This big triangle is not a right triangle, so I can't use Pythagorean theorem on it. But I do know that this is, because that's a linear pair, so I know that's a right triangle. So if I look at this one right here, here's what I notice. I notice that one side is 6 and one side is 10. Right? You can carry on and you can do Pythagorean theorem all day. That's fine, no problem. However, I notice that this is a multiple of 5 and this is a multiple of 3. So I just need to make sure they're the same. This is 3 times 2, right? This is 3 times 2. This is 5 times 2. Well, if I know my triples, then I recognize that this is a 3, 4, 5 multiple. That means this is 4 times 2, or 8. So I already know, without having to do a whole lot of math, that that side, that leg of the triangle is 8. Now it's 8, 12, and then whatever this number is. Well, let's check and see if this is a triple. Well, this would be 4 times 2, and this was 3 times 4. So these are not multiples of 3 and 4. They're not multiples of any of the other ones. So this is not a triple. So I could use it here, but I can't use it here. So sometimes you have to use Pythagorean theorem, but sometimes you don't. This would be 8 squared plus 12 squared is equal to x squared. You get that 64 plus 144 is 208, right? Find the biggest perfect square that goes into 208, and you get 16. So the square root of 16, and 16 goes into it 13 times. The square root of 16 times 13, the square root of 16 is 4, and the square root of 13 is a decimal. It doesn't come out pretty, and so it's 4 square root of 13. And so the answer then is 4 square root of 13 if we leave it exact. That's exact. You've got to understand the difference between exact and approximate. 4 times the square root of 13 is 14 point. But see, look at all those decimals, right? As soon as I say 14.4, that is not approximate. I mean, that is not exact. That is approximate because those numbers exist, and as soon as I cut them out, I've made it not, right? This is what I call a NASA number. If they're going to send me to the moon, that's the number I want them to plug into the calculator. If I'm just going to Home Depot and I just need a roundabout, right, I'm going to go with 14.4, even though it was 14.42. I might even round up to 14.5 if I'm going to Home Depot to buy a board, right? But this is approximate. Please know the difference. All right, this last one. Find the perimeter of triangle ABC. So one of the things, notice that this is on a grid, and the nice thing about it being on a grid is we can start to use Pythagorean theorem instead of the distance formula. Well, we need to turn this into a right triangle. This is not. So what I want to do is to find AB, I'm going to use this little pink triangle right here because the hypotenuse of that pink triangle is the side that I'm looking for. AB, so I would go up 5, and it goes over 12. Well, I notice that's a 5, that's a 12. That means there's a Pythagorean triple. So without having to do Pythagorean theorem, I automatically know that AB is 13. Never had to do a Pythagorean triple, or never had to do Pythagorean theorem. It's a triple. Use them when you can. And then I want BC. So if I want BC, I'm going to draw in this right triangle right here so I can see it. BC is my hypotenuse. One leg is 3, one leg is 4. Well, that's 3, that's 4. That means the hypotenuse has to be 5. Let me point out one thing. Be careful here. If this is 5 and this is 3, this is not a 3, 4, 5 triangle. Okay? This 3, 4, 5 doesn't work because the 5 has to be on the hypotenuse. Because this can't be 4. The hypotenuse can't be shorter than one of the legs. So if it's this way, right, if it looks like this and the hypotenuse is not the longest side and it's not a 5, then you can't use the triple. You have to do Pythagorean theorem like you always do. Doesn't always work. Pythagorean theorem doesn't always work. Then this last one, I want AC. AC is the hypotenuse of this right triangle right here. This has a side length of 2 and a base of 16. Double check that. 2, 4, 6, 8, 10, 12, 14, 16. Yes. Now, that's not a triple. There's not anything with a 2 and a 16. So in this case, you do actually have to do Pythagorean theorem. Let me write this down. BC was 5. So then Pythagorean theorem, 2 squared plus 16 squared is equal to, I'll just call it x squared. You can call it c, whatever you want. 4 plus 256 is 260. 260 is equal to x squared. This time we're going to, we'll go ahead and round it so that we can actually get the perimeter and add them together. So the square root of 260 is 16.12. Right, you type that in, square root of 260. Okay, it's all those decimals. I rounded it, so that's approximately 16.12. And add that together, 16.12, you get that the perimeter is equal to 34.1. So these triples are very, very important. Take the time to memorize them. There are more, but at least know these two. Okay? They're extremely important and they're very, very useful. Pythagorean theorem is a squared plus b squared is equal to c squared, where c is the longest side of the hypotenuse. So previously we learned about Pythagorean theorem. The Pythagorean theorem says if the triangle is a right triangle, then a squared plus b squared is equal to c squared. But today what we're going to do is talk about the converse of it and why it's useful. So the Pythagorean theorem is only useful when the triangle is a right triangle. So the way that we use the converse of the Pythagorean theorem is to test to see if a triangle where we already have the sides of the triangle, we want to know, is it a right triangle? So the way that that works is if a squared plus b squared equals c squared, notice I wrote it backwards and there's a reason for that, but it doesn't matter. Either c squared equals a squared plus b squared, or a squared plus b squared equals c squared, then the triangle is a right triangle. So that is the converse. Remember, you just flipped the order. Here I said if it's right, I can use Pythagorean theorem, but if I have three sides, I can use Pythagorean theorem to determine if it's a right triangle. In a minute, we'll talk about what happens if it's not a right triangle. What is it? Because it has to be some kind of triangle if it's a triangle. So the first thing, the way that this looks, is to tell whether a triangle with the given sides is a right triangle. This is one of the things like I talked about yesterday where I wanted to know if it was a right triangle. If I measure my measurements, if you want to know if a room is square, then you can take that room, you can measure the wall, measure the diagonal, and you can see if your Pythagorean theorem sticks. Okay, so what that means is find your longest side. I'm not sure how long 4 root 3 is, so I type that into my calculator and I find out that that is 6.9 and some decimals. So I can see that 8 is my longest side. It's not always going to be last in the list. It's the longest, so be careful about that. That's why I've got it right here. It's not always going to be the last one in the list, so just always check. So here's what you do. You say, okay, I want to know if this is a right triangle. Well, if it's a right triangle, it'll fit the Pythagorean theorem. A squared plus, be careful here, b squared, and I want to know, is it equal to c squared? If it's equal to c squared, then it's a right triangle. If it's not equal to c squared, then it's not a right triangle. So we test it. 4 squared plus, make sure you do all of it, 4 square root of 3 squared is 64. 8 squared is 64. And still I'm asking, is that true? Yes, 64 is equal to 64. Therefore, yes, it is a right triangle. Okay, so yes, it's a right triangle because that's a true statement. So 10, 11, and 14, we want to know if that's a right triangle. If I have sides 10, 11, and 14, is it going to make a right triangle? A squared plus b squared, if it is, then a squared plus b squared should equal c squared. C is the longest side, which is 14. 10 squared plus 11 squared is 221. 221 does not equal 196. And since those two are not equal, Pythagorean theorem doesn't hold true, so then it's got the inverse. If a squared plus b squared is not equal to c squared, then the triangle is not a right triangle. So it's not a right triangle because this statement, the Pythagorean theorem, didn't hold true. I need to double check. The square root of 61 is 7.8, so it is indeed my hypotenuse, not because it's last in the list, but because it's the biggest. You want to test a squared plus b squared is equal to the square root of 61 squared, c squared. Okay, again, we're asking, is that a true statement? That's what I want to know is that a true statement? Well, 5 squared plus 6 squared is 61, and the square root of 61 squared is 61. Since that is a true statement, then yes, it's a right triangle. Okay, the way that you might see this on a test show up is which sides do not form a right triangle. Now in this case, if you know your triples, it's going to help you out a little bit, okay, because it's going to help us. Triples only work if it's a right triangle. We don't even have to go through Pythagorean theorem because we know it already works. So look at 5, 12, 13. 5, 12, 13 is a triple, so it works out, right? You can test it. 5 squared plus 12 squared is equal to 13 squared. So if you don't know your triples, you can check it out. But it does give you a shortcut so you don't have to do, because we have 4 of these problems to work. So if we know our triples, then it helps out a lot. So this is 10 and 24 and 28. So this is not a triple, even if we check this is 5, this is 12, this is 14. We don't have a 5, 12, 14 triple. So we do need to check it. Just because it's not a triple doesn't mean it's not a right triangle. 10 squared plus 24 squared, and I want to know, is that equal to 28 squared? 10 squared and 24 squared is 676. 28 squared is 784. They are not equal to each other, so that one is the one that's not a right triangle. Now, just so we can see the rest of them, 15, 36, and 39. I notice this is 5 times 3, this is 12 times 3, this is 13 times 3, so that's a 5, 12, 13 triple, so that one works. And then this is 50, 120, and 130. If you divide all of those by 10, you get a 5, 12, 13 triple. So in every case of the ones that we had that didn't work, they were all triples, and not only were they triples, they were 5, 12, 13 triples. So always look for those triples and see if you have them, because it'll help save you a lot of time. Now, what if it's not a right triangle? What kind of triangle is it? Well, we can use Pythagorean theorem to determine that too. If it's not right, okay, it has to be something. So if it's not right, it is either acute or obtuse. Now, you notice earlier I wrote c squared is equal to a squared plus b squared. If that's true, it's right. Well, the reason I wrote it that way is because of this right here, because I think this makes more sense. If c squared is greater, then the triangle is obtuse. If c squared is less, then the triangle is acute. I just think that that makes sense, like less than goes with acute and greater than goes with obtuse, but it's whether c squared is greater. If we flip this around, it would be a squared plus b squared is less than c squared, but c squared is still greater, right? Because it's still opened up to, if you read it backwards, c squared is greater than a squared plus b squared. And the same thing here, a squared plus b squared is greater than c squared. What I care about is c squared, okay? That's the part I care about, and so that's why I wrote it in this order. If c squared is greater, then it's obtuse. If c squared is less, then it's acute. And I just think that's easier to memorize than the normal way that we use Pythagorean theorem. So it says, decide if the given lengths form a triangle. So that's way back to the first day, right? The sum of the two short has to be greater than the longest. So first we're going to check if it's a triangle. So just because it's drawn, these are not drawn to scale. So just because it's drawn doesn't mean it's a triangle. The sum of the two short has to be greater than the long for it to be a triangle. Okay, so that's the first thing that we're going to do. And then the second thing is, if it is a triangle, then we're going to classify it as a right, acute, or obtuse triangle. If it's not a triangle, it can't be right, acute, or obtuse. Okay, so first thing, let's check to see if it's a triangle. So is it a triangle? Okay, let's check. So my two short sides are 5 and 7. So I'm checking to see 5 plus 7 has to be greater than 11. Is that true? Yes, it's a triangle. Now, if it's a triangle, I want to know what kind. Notice I do not square it to check to see if it's a triangle. Okay, that's different. You aren't using Pythagorean theorem to see if it's a triangle. You're only using Pythagorean theorem to see what kind of triangle. So what kind? So I do my c squared first in this case. So 11 squared, 11 would be my c because it's always my longest, my hypotenuse. So my c squared, so I do c squared, and then I do a squared plus b squared. These two, the order doesn't matter. 5 squared plus 7 squared. And I want to know, what's the relationship? Are they equal? Are they greater? Is it less? Which one is it? Well, c squared is 121, and 5 squared plus 7 squared is 74. Well, c squared is greater, okay? C squared is greater, which means it is obtuse, okay? Yes, it's a triangle, and so that means it's an obtuse triangle because c squared is greater. That's what we care about, is what's the relationship to c squared when we're testing what kind of triangle it is. Again, we've got this 4 root 3, right? This was 6.9, so I know that 8 has to be my longest side. I want to know, is it a triangle? Let's test it first, right? The sum of the two shorts. So 4 plus 4 root 3 has to be greater than 8. That's my first question. 4 plus 6.9 is 10.9. So that is greater than 8. So yes, it's a triangle. Now the question is, what kind? To do that, we do Pythagorean theorem. I'm going to do c squared first, and I'm going to compare that to a squared plus b squared. That's a 3. Okay, be careful with that on your calculator. This is 64. This is 64. It is equal. Since c squared is equal, that means it is a right triangle. It's equal, it's right. If it's greater, it's obtuse. If it's less, it's acute. Check to see it's a triangle first. That's the first instructions. Decide if it's a triangle first. This is just like reading. You know, like when you write, you have to go make sure you answer all the questions. You got to do the same thing in math. So 2 short sides have to be greater than the third side. 8 is smaller, or 12 is greater than 8, right? So yes, it's a triangle. And now I want to know what kind. To determine what kind, we use Pythagorean theorem. That's my c. So I check 8 squared, c squared, always do that first. You don't have to, but that's the easiest way to remember it. And then compare that to 5 squared plus 7 squared. 64 and 74. So in this case, c squared is less. C squared is less. When c squared is less, it is an acute triangle. Okay, last one on these 4. Let's check to see if it's a triangle first. 2 short sides has to be greater than your longest side. So check to see 3 plus 4 has to be greater than 7. That's not true. 7 is not greater than 7, so it's not a triangle at all. Y'all, be careful. Here's what students do. They'll go, it's not a triangle, and then they'll go in they're like, I did this, I did that. Follow the pattern, right? And they'll be like, now I'm going to do a squared plus b squared equals c squared. Well, you know what? You can do that, but it wasn't a triangle in the first place. So why go through the mess of determining what kind of triangle it is if it isn't a triangle anyway? Okay, so you just stop. You don't have to do anything else. It's not a triangle. And like I said earlier, this is how we can test something. So we're making a canvas frame for a painting using stretcher bars, those wooden frame around the wooden bars around the frame. The rectangular painting will be 10 inches long, or I should have put it here, 10 inches long and 8 inches wide. Using a ruler, only a ruler, not a compass, we don't have, or a protractor, we don't have a way to measure the angle. How can you be certain that the corners of the frame are 90 degrees? So the question is that 90 degrees? Or is that 90 degrees, right? If it's a rectangular, this is 10, this is 8. So the question then, what you would do is, if I want to make sure that that is a right triangle, what I need to do is check to make sure it's a rectangle. I need to make sure that there's a right triangle. So if I tested it, if I did a squared plus b squared is equal to c squared, I get that c has to be 12.8. So what I would do is I would measure the diagonal. And if it's a right triangle, if it's a right angle, and if that's rectangular, then it should measure measure the diagonal, and it should be 12.8 and some change, right? 12.8, and to make it be a right angle, to have a right angle in the corner, because that right angle, right, that rectangle has 2 right triangles in it. So if that diagonal is 12.8, then that angle is a right angle. If it's not, then you need to do some adjusting with your frame so that it can be at a right angle. So we can use the Pythagorean theorem to find out what the missing sides are, but we can also use the converse of the Pythagorean theorem to find out what kind of triangle it is. If it's a right triangle, and if not, what kind of triangle is it? If it's a right triangle, then c squared is equal to a squared plus b squared. If it's obtuse, c squared will be greater than a squared plus b squared. And if it's acute, c squared will be less than a squared plus b squared.